Good evening, fellow students. Today I prepared some nice motivation, video to give you more encouragement to prepare your pathway to get 7 for the main exam. So what sort of a mindset we should have and how we should orient our direction of the practice towards the main exam is prepared for this video. So without further ado, let's get started. Right? How do we get 7 up? Right? So what we want to do is to be able to get the 7 for the main. And then I want to prepare, and what sort of a mindset now, since it became the February, we only have maximum 10 weeks to prepare, and let's see how we can prepare for the upcoming test for the 7. Okay. So the very first question I want to ask you, since now it's the dawn of February, which pill do you want to take? Right? Do you want to take the red pill of studying mathematics or blue pill of studying mathematics? Right? If you take the blue pill, for that is, our mindset is going to be the following. We're going to be waiting for my problems to solve themselves, right? Are we going to be, lazy, sluggish to ask the problem to solve themselves, or are we going to actually engage and become the Superman of mathematics, especially for the IB, right? So in order to become Ubermensch, what do we have to prepare accordingly for the main exam is the following. Okay, what we need to do is to have a mindset of Dory, a fictional character from Finding Nemo. All right, what we need to do is to use her quote: "Just keep solving." Okay, just keep solving. Just keep solving. Right, we need to keep solving the problems. For the mathematics in general, it's not about how many stuff that you know. It's not about how much of integration or how much calculus, how much probability you know. It is about how many relevant problems you have solved. Even if for linear functions or quadratic functions, which sound very simple, if the problems are twisted, it can be very challenging. So what you need to be exposed is the multiple types of questions, all right? And those various types of questions can be seen on many textbooks, right? So I wanted to give you an example of a recent November 2024 exam papers and how those hard questions could have been seen on a textbook, right? So the very first tip that I want you to have, that I want to give you for the 2025 February is just keep solving, right? So if you have a look at the question number, 11 of paper 1, right? It was about the Maclaurin series, all right? It was about the Maclaurin series, especially for this function. And for those of you who have done a bit of practice before with the extensive trigonometry or calculus, realize that this is actually the a hyperbolic tangent, right? So if you have a y is equal to e to the power of 2x minus 1 over e to the power of 2x plus 1, and if you want to divide top and bottom by e to the power of x, you get the e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of x. That's what we have, isn't it? And this question is about the extensive differentiation, implicit differentiation, and then getting the hands of the Maclaurin series. Okay. But this question could have been seen, I believe this is a Pearson, Pearson textbook, right? And in here you already could discuss the Maclaurin series of a hyperbolic cosine, and it follows up with hyperbolic sine, and hence deriving the hyperbolic tangent. And point I want to make here is many of the hard, challenging end question of paper 1, 2, or 3 for that matter could have been seen already in the glimpse of the textbooks, right? So what you therefore have to be doing right now is to be more exposed to many types of questions from different textbooks. Okay, let's have a look at number 2. So another hard, challenging problem from paper 2 was the combinatorial problem. It was, I believe, a sushi restaurant problem. If you pay attention to the part B, it says next day A, V, and P are joined by 3 additional people, so there are 6 people, aren't they? And then what they're saying here is, I want to have A, V, P grouped together, and then the remaining 3 people sit as randomly as they want, and the total seats of 12, right? There are 12 available seats, and for that problem, part B could have been reflected well on a question from the textbook Haese, all right, on the Alice problem, right? So Alice is booked 10 front row seats for basketball game, and in this problem what you had to do is we had to make sure that her friends are sitting, 2 of her friends are sit next to her, and then the remaining seats can be taken by 3 remaining people. And this question number part 3 is very similar to this sushi factory question. Only difference is that this has got the 12 seats and this has got the 10 seats, and the setting is the same, right? So what I want to make the comment here is, if you want to solve your upcoming May exam question well, paper well, you have to solve many questions from the textbook. Is my word of advice, right? So let's have a look at the paper 3. The first question in paper 3, I believe it was about the fish in the lake, right? Then what you had to be doing was to solve this recursive relation, right? You're actually solving 3 types of a sequence in IBID syllabus, explicitly with the arithmetic geometric, and another one as usually given as a challenging problems are the recurrence relation like this, right? And in fact, if you look at the AA Oxford book, it's got nice subchapter of discussing the potential internal assessment topic known as the Tower of Hanoi. This is the recurrence relation. This is the typical question that you do when you're solving a problem like paper 3 or challenging problem from paper 1. You know, the Mary grandparents and her grandparents giving her money until she becomes 18 and she buys herself like the birthday present of $1,000. And those questions are the Towers of Hanoi. Anything with the financial sequence and series, in fact, with the repayment or superannuation, is in fact solving with the Towers of Hanoi. So if you are actually, reading over these sort of chapters also when you're practicing on certain chapters such as a sequence and series, you would have seen that problem already, right? So my point here is textbooks are usually amazing, right? There's not a single bit that you could waste them, right? It's very, very helpful tips here for the internal assessment that was actually given for the paper 3. And another nice, amazing problem of the palindromic polynomial in the question number 2 of a paper 3 in November 2024 is the investigation of a polynomial where it has got the symmetric coefficient, right? And then what you had to do, I believe, was working with the pattern and what happens if you put x equal to -1, etc., was the question number 2. In fact, this can be seen in many of the textbooks, including the IBID. For me, this is the GOAT, right? This is the GOAT of the IB preparation, but usually it's way more challenging, right? So usually way more challenging. It's a very old book, but gold. Okay, and if you look at the question number 18 of a chapter on that book, it talks about that sort of a symmetric polynomial, right? Symmetric coefficient polynomial, which they didn't mention about the name, but it does have the behavior of the symmetric coefficient. And surprisingly, this polynomial can be now converted into this trigonometric function. Right? It's very random, isn't it? Another question that was also seen on that textbook was question number 12. If you look at it, now they're talking about some complex number, right? Complex number, and another polynomial degree 4 question where the symmetric coefficients we are given. So as you can see, I got the 3, 3, 2, 2, and 1, right? And then for that, how do we solve it? Is the challenging question from the textbook, which you could have solved before the November 2024 and well prepared. What is it? The exam question like the paper 3. Right? So this is amazing. And in fact, this paper 3 in November 2024 can be extended to a very great idea for the internal assessment or extended essay. I will give you an advice. So this paper 3 in November 2024 can be combined with the question number 12 of November 2024 paper 1. Right? So I believe this question number 12 it was the most complicated part, especially with the part E in this year of exam. But it's something to do with the roots of unity, and surprisingly, that roots of unity with the complex number can be well combined with the palindromic polynomial. And I believe in this question, at the end of the question, you had to deal with when the degree was n, degree n was odd. But what about if the degree was even? What sort of a pattern can we have? Is also a very interesting extension you can make. And for me, extended essay or internal assessment can be always developed very nicely if you say, I was solving this exam question and I was wondering what if n was even, right? So then this delves into the realm of the complex number and polynomial and roots of unity and etc. and can be studied very extensively. So I'm planning to make a video about this, so please look forward to. But my point here is, all those questions, the hard questions from the November 2024 could have been seen on the textbook, right? So I don't expect you to be solving all the 5 different textbooks from Haese, Oxford, Pearson, Hodder, IBID, etc., etc. There are too many books, right? And of course, if you have time to solve them, that's good for you. It's always excellent. But just devour one particular book. You choose one book. One of them, any of them is amazing, right? So, but choose one particular book that your school uses it, then devour it, right? You have to solve from head to toe to take the root to top, right? We want to be on the root to top, right? So obviously it would take some time. It would take 1, 2, 3, 4, 5, 6, 7, right? Scores to get is not an easy path, but you will definitely be able to do so if you follow the tips from your teachers or me, right? So you do have to keep on solving, like Dory. If you take this route to top, what you'll be enjoying after the May in the summer is a rooftop view. It's gonna be the rooftop view of a summer vacation. You're gonna be enjoying the cocktail in the rooftop view with the 7 in mathematics. Okay, so make sure you are willing to put some hard work. That's my word about. But the thing is, the problem I think the IB students have is that they often do not realize their house is set on fire. Okay, well, my point here is the following. For me, the biggest difference between the IB and SAT is the following. For the SAT, you already know yourself very well. Okay, there are many chances to be self-assessed because you can take the test anytime you want. So the first test they take for the SAT, they get very humble because they realize that they're not up there. They need to prepare a lot, right? So got 100 tests on the SAT, cry. So for SAT, you already know, but for the IB, okay, we do not know because we only take the exam only once in May or November. Wherever you are, whichever region you are. So my point here is you have to be assessed well and often, right? And you have to put the bar a bit high so that you take the test under time pressure, maybe weekly basis, and know your own score is critical. It's critical for the success of the preparation. So you cannot just be solving the problems. You have to get assessed. You have to be given the mark of your understanding. For that, you can extensively ask your teacher to set up more mock tests, for example, or you can be honest to yourself and take the test as many times as possible, and then grade yourself with the honest mark and see yourself whether you are getting 5, 6, or 7. Right? If you're getting solely 7 for taking many tests, you can be relaxing. You can be relaxed from the math. You can spend more time on the other subject, but you really have to balance yourself. Right? If you're getting an average of 5, then you know yourself that you have to try way harder, and for that can be only understood if you're assessed more often. So for my word of advice is that you have to take the mock test as often as possible and know your own understanding given as the mark. Okay, it's very important. And you know what? I will tell you what's even more difficult because commonly, right, the schools they usually assess your understanding based on the past exam paper, right? So students often just take the past exam paper and prepare with that. They already know the answer, and so then it would become a shame because they will be getting 7 for the mock test, but ends up not a good score for the end exam because for the actual May exam because they've been seeing the answer already, right? Because they already seen that problem in the mock test. So it's a really different sentiment. So what you really want to do is to be exposed more into the new types of questions and see if you can still display your understanding well, right? Instead of having seen those questions before and take it well in the mock test, in the school mock test, all right? So you can ask your teacher, please try to avoid giving us the past exam paper. At least try to change the number and guide us through, right? So that's important. So what's important? Knowing ourselves is important. Okay, and for that you got to take the mock test. Is my word of advice. You have to know your own score, and yes, it can be a little spicier, right? So of course, if you look at Dragon Ball, what does Son Goku do? He puts the heavy clothing on himself so that he can be lighter when he actually fights, right? So during your practice, you have to challenge yourself more with the harder problems and see if you can do them well. Okay. So what you really should be using the most right now is your teacher. Okay. your teacher is not a fiend, right? You think that he's a Professor Snape who's trying to give you as many problems as possible, but at the end of the day, they are in school because they want to have students, right? So what you have to do is to understand their curriculum and ask them to challenge you more and demand more, okay? So that you can put your bar high to take the test well. So what I can do for you is maybe I can give you the weekly questions to sort of challenge yourself, like a brain tease, and stay well trained before the main exam. So what I prepared today is just brought one question. Okay, I just brought one question for AA and AI, and see if you can try them now. Okay, so I've got these two questions because that was the question of this week from AA student and AI student, and I thought it was a very nice question to discuss with the other people. So let's have a look at the one question each. Okay, so this is gonna be the February week 1 question, and we put one for each AA and AI. Okay, so the first question is a question from the AA student. What he asked me was, how do you prove that the tangent 3 theta is equal to given as this? Well, what you can be applying is the triple angle of a sine and cosine. This is usually a very common question to be asked using the complex number. Please be able to derive using either complex number or the compound angle. Okay, those are the things that I would ask you to practice. Okay, good job. So then our aim is to show the triple angle is going to be this. How would you do it? Like, what I want you to do is to pause the video and try yourself. Okay, I want you to pause the video. Very good. On this one, what I would try to do if I have the triple angle of a cosine and sine is, of course, to use the understanding of a tangent. It's just a sine over cosine, isn't it? So I already have the sine over sine triple angle and cosine triple angle. I just put the sine 3 theta and cosine 3 theta respectively. And what I would encourage you to do every time you want to derive something of a tangent is to divide by the highest power of a cosine. In this case, I would divide everything by cosine cube, and that's a very common way to derive something of a tangent that you have seen already when you were doing, for example, tangent 2 theta or tangent compound angle. When you were deriving such identities, the kick was that you have to divide by the highest power of the cosine. And in this case, the highest power of cosine was 3, so I divide by the cosine cube. And then you try to simplify the numerator and denominator. So if I simplify the numerator, my friend, I'm left with this, sine cubic over cosine cubic will be replaced by the tangent cubic, but I still have this nasty term of the 1 over cosine squared, which is not exactly the tangent. But you realize that it can be replaced as a secant square, and I'm going to leave it there for a second, okay? And then for the denominator, I had this form, and what you realize that it cancels out, and this also gives you the secant square, doesn't it? Right. So, and on this one, what you can do is to convert this form into something of a tangent using the the Pythagorean identity. For the secant square, can be replaced by the 1 plus tangent square theta. Right. So every time we have a secant square, we love it. So what you can do is simply just apply the Pythagorean identity into the given form that we derive using the triple angle of the sine and cosine respectively, and then expansion will give you the desired form, right? That was the one thing that we had to do. And the very common question to follow up is to be able to find the exact value of a tangent 15 degree and tangent 75 degree. So let's have a look how this question can unfold. So in this case, I have this triple angle of a tangent. And what we want to do is to be able to derive the 15 degree. Okay, so for that, I'm going to put the theta as 15 degree. Okay, if so, what you get in the form on the left-hand side, that becomes a tangent 45. All right, so that means it's going to be 1, right? Because it's a special angle. That's great. But on the right-hand side, I got a bunch of a tangent 15 degree. Okay, for which I don't know the solution yet, so I'm going to just substitute that as a t. And if you see the expression, I got this compound angle of a tangent. And that is great. If you rearrange, what you see is that you got a cubic polynomial like this. Okay. Then our job is maybe trying to solve this equation. Maybe I'm trying to find a root of this polynomial, which is going to represent for the tangent 15 degree, but it's a cubic. So what we want to do is maybe try to do the rational root test and see if, for example, t equal to 1 or negative 1 would work. Let's take a look. So what sort of a polynomial would work? The t equal to -1 actually works. So the given previous cubic polynomial can be substituted as this, where t now, in this case, remember, was still 15 degree. And I know tangent 15 degree must be positive because 15 degree is actually an acute angle. So now it cannot be -1. So he's not going to be the solution coming out of this linear factor. In fact, what I need to do is to get it from the quadratic form, right? But it's not factorizable, so what I'm going to use is the quadratic formula. So I've used the quadratic formula for you. What you need to decide, however, is that this is a tangent 15, and tangent 15, tangent is a function, so it must pass the vertical line test, so it must be unique. So I don't know if it's going to be positive or negative. I still have to verify. How would you verify whether it's going to be positive or negative? What would you say? Good. What significance do we have for the tangent from 0 to, well, I wrote it in radian, but let's write it 90 degree, is that if you put it on the graph, it's always increasing, my friend, where the 90 degree is going to be your vertical asymptote. And in this case, what you realize is that the 15 degree is a pretty small value. And if you compare that with, for example, 45 degree, where the tangent 45 is 1, tangent 15 degree must be less than 1. So in the choice of a positive negative, if you had 2 plus root 3, that's a contradiction, because it cannot be bigger, it cannot be smaller than 1. So what I need to realize is that it must be 2 minus root 3 for the tangent 15 degree. So that's how we can use the tripling of tangent and cubic polynomial and derive the tangent 15 analytically using the polynomial. Very good. But let's have a look at tangent 75. Right? What about the 75? Well, what we can do is apply into the triple again, this time theta to be 75 degree. But for the triple, I get the tangent 225, where I know that is on the third quadrant, okay? In the third quadrant, tangent is a positive. So then I'm going to get the same situation. It's going to be the same polynomial, which then I will have the same solutions again. And the only thing that I have to bear in mind is that I will be in the dilemma of deciding whether it should be 2 plus minus root 3. But this time 75 degree is pretty close to 90, so it must be pretty big actually. So it must be bigger than 1. For that case, I know it must be 2 plus root 3. Okay? So being able to verify whether it's going to be minus or positive in the middle using the trig function is the key understanding for this. So that was a very nice warm-up question for the AA. Now let's have a look at the first weak question for the AI. Asked by a student. Right, so let's have a look at this question. So a student brought a question with the Poisson distribution, so let's read it carefully. A number of birds seen on the power line on any day can be modeled by a Poisson distribution with the expected value of 5.84. Okay, and it says find the probability that during a 7-day week, more than 40 birds have seen on the power line. Okay, well, the very first thing you want to do for any distribution problem is that you got to define your random variable first. So I define my random variable as a b, which is going to be the number of birds seen on a day. And it's given as a Poisson distribution, no problem. I'm going to put it as a Poisson distribution with the expected value of a 5.84. But for the Poisson, I really encourage you to indicate the time interval as well. This is just a 1 day, isn't it? Okay. But now you realize it's asking for the 7-day week. So the interval has increased. That means your expected value has to be increased with the same scale factor. In this time, it's going to be 7. We multiply the 7 on it, then the new expected value is going to be 40.88. And now, for the distribution problem, what's important is that from the wordy paragraph, you should be able to convert into the expression, the statistic expression. It says more than 40 birds, doesn't it? Right? For that case, I realize it's gotta be the CDF. So what I need to do is to define this as a Poisson CDF. I'm gonna write it as a probability of B7 bigger than 40. But for the purpose of a calculator, what you always have to do for the CDF is make the inequality as less than or equal to. So I will put it as the 1 minus probability of B7 less than or equal to 40. I want you to realize I'm using B7 because it's for 7 days, not 1 day. Right? Therefore, if you put that in the calculator, you should be able to get the probability easy peasy, lemon squeezy. For the distribution problem, I strongly encourage you, please define your random variable and specify the particular distribution. If it's a binomial, you need the NP. If it's a Poisson, you know you need the expected value or variance. Okay? But let's have a look at the question part B. Says, on Monday, there were more than 10 birds seen on the power line. Find the probability of there being more than 40 birds seen on the power line from the Monday following Sunday inclusive. You know what? For this one, I would say it's one of the most challenging problems. It is one of the most challenging problems for the distribution problem in IB. Okay, I will tell you that actually. For me, what's very challenging for the AI is that you have to read well. Okay, because I want you to pause the video as an AI student and tell me how you want to approach. Spend at least 20 or 30 minutes actually. Spend 30 minutes at least. How you're going to be solving this problem, and then watch the video again. And for me, what's very difficult is the interpretation. I read the question carefully, and what's important for the AI is that for the English paragraph, I gotta put that into the mathematical expression. But when I see this, I don't know what expression I have to do. I don't know whether I'm gonna do PDF or CDF, union, intersection, or conditional probability. For example, if I think about the conditional probability, I'm usually given the sentence like the given that, or if A then B. Those are made up vocabulary for students to be able to tell that it's going to be conditional probability, isn't it? For the practice that we do in school on the textbook. But for this exam question, they didn't use none of that, right? They didn't use any of the given that or if A then B sort of a sentiment to give you the impression that it's going to be the conditional probability. But it is indeed the conditional probability, because what has happened first? The condition that happened here is that on the Monday there are more than 10 birds. That's given. That's your condition. Okay, that's given hypothesis. Then I need to find the that I've got the more than 40 birds on in 7 days. Right. That's the probability that I need to find. And given that on Monday there were more than 10 birds seen, right? So that's the probability. And from that sentiment, even though I don't have anything like the given that, I realize it gotta be the, conditional probability. So that was the first problem with this question. It's actually difficult to interpret, okay? Unless you have seen the multiple ways of deriving the conditional probability. So what I'm going to do here is, yes, I'm trying to find birds more than 40 in 7 days. Given that on Monday I got more than 10 birds, and that's a conditional probability. In fact, the conditional probability with the Poisson distribution is very challenging. It's not easy. It's very challenging. But let's take a look. So I've got that, and I believe if it's a conditional probability, I believe your expected value is insignificant. I believe that this probability will be independent from the expected value for the Poisson distribution. You can write that as your internal assessment. But for this case right now, I realize I'm going to use the conditional probability definitions. It's going to be A intersection B over B. So those are the things. And that intersection, you have to really think hard, okay? Now I have on Monday more than 10, and I want more than 40 birds in 7 days, okay? So how do I think of it? When you know the role of independence is huge for binomial or Poisson, okay? So since now I have 7 days, but think about it. I had already accounted for the Monday. Then the remaining 6 days will account for the rest of the birds. Remember, I wanted to have more than 10 birds on Monday. That means the remaining days should have the rest of the birds so that it accounts for the more than 40 birds. You get what I mean? So in this case, what I need to do is I need at least 40 minus B birds, where B was the number of the birds on Monday, okay? So for example, when I say, all right, imagine I had 11 birds on Monday, because remember what I had to do was more than 10 birds on Monday. So imagine I have 11 birds on Monday. That means on the remaining 6 days out of 7 days, so I'm gonna write as a B subscript 6, has to be more than 29 birds, you see? So that it's going to be in total of more than 40 birds. Or I have, B equal to 12 birds, and that's gonna be probability of the birds in the 6 days bigger than 28 birds. That's how we're gonna count for, you see? And I'm gonna keep adding this and adding this up until all the possible cases, because on Monday, if I get very lucky, you might have seen actually up to the 40 birds, you see? So let's take a look. So how we are going to understand about this situation is actually a massive series. You're going to go all the way up to, If I was lucky, then it's going to be, On Monday, I have 40 birds. That means on remaining 6 days, I have more than 0 birds. But what if I have seen already more than 40 birds on Monday, which is very unlikely, by the way. But in that case, I don't have to count for the remaining 6 days because I already achieved more than 40 birds. So in fact, the series that I have described in blue will be described in this sigma notation. And then you also have to account for a very lucky day on Monday, more than 40 birds will be the representation of that intersection. And I do not think it's easy to understand at first, all right? That's why it's actually one of the most challenging problems, I believe, in the distribution question history for the IB, for the AI students. So please take your time actually to see whether you can understand this representation of the conditional probability or intersection with the Poisson distribution. Super, super nice question, okay? And then therefore, if you put that in the calculator, the likelihood is very huge because you already have seen more than 40 birds on Monday, you see? Sorry, more than 10 birds on Monday. Is it likely that you're gonna see more than 40 birds throughout the 7 days? So it's a very lovely AI problem. I believe you should really try this question alone. Even after having watched this, I don't think it's easy to follow. So please try yourself again and use your calculator to see if you get the probability also, all right? But yes, that's pretty much I have prepared today. You know, what I wanted to give you is that now we only have a few weeks left. Honestly, 10 weeks is gonna, fly very quickly. So what you need to do is, number one, be Dory, okay? Keep on swimming is the first thing you got to do. Number two is that you have to know yourself. I really encourage you to be like the mindset of the SAT students. You have to take the official test without having seen the mark scheme, without seeing the solution, and mark yourself, or ask your teachers to mark it, right? Therefore, you know what scores you're going to get. And the third thing that we did today is, go over some questions that the students have asked me from the A and AI, which I think is equally nice to share with you. And I intend to do this every week, so please stay tuned. Okay? But that's pretty much it for me today. Happy Lunar Calendar New Year, and I will see you next time. Thank you. Happy New Year. Thank you.